All right, welcome to episode 11. We are going to be covering list comprehension. So, list comprehension is just a thing that offers a shorter syntax for when you want to create a new list based on the values of an existing list. So, normally you would have to do a for loop without list comprehension, so we can just have this list here and demonstrate. And then if we have list y and it's an empty list and we want to move all of the items, append all of the items from list X into list Y, we would have to do something like this for num in X, and then we can just list dot append, so append num, right, and then we can print Y. So do that, we launch our terminal, we go ahead and we run 11.py, and you see that we're printing Y, so we've appended everything. But this could get pretty lengthy sometimes, and it's just a different type of syntax to do the same thing, and basically to do one line of code. So in here, what you could do is instead of having this for loop, which we'll just actually comment that out, you could, and we'll come out this version of Y. So here we'll do the list comprehension version. So here you would just have Y equals the list num for num in X, and then you could print Y, and you see we get the same output, and you don't need the colon at the end to execute it or anything like that. So this is just a shorter syntax, and again, num is just a variable name that I'm using to represent each element in this list. X is the name of the list. So the name of the list that you're taking from is important, that you're looping through, but you can name this variable anything as long as it's the same name right here, and it will do that. And you can also add other conditionals, so you could say like an if blank in X. So you could say like num for num in X if 1 in X, something like that. And then it will check to see if 1 is in X and do it. So we'll see with 10, and we don't get anything because there's no 10 in the array. But as long as there's a 1 in the array, it will keep doing it. And you can use this in combination with something like pop or something like that, where you're removing numbers, and then at some point the loop will stop running as well. And just for note's sake, I'll go ahead and type out both versions here so that you have both. So we'll say Y num for num in X. So that was the original list comprehension that doesn't have any kind of a conditional, and this one has a conditional here. So important to know that you have those options. The syntax for it is that the return value is the new list, which means the old list is unchanged. So this list is just like up here, how we looped through this list and we appended to Y. We're not changing the values of X. Like when we return an empty array down here, X is not empty. So for example, we can just print that out. I can uncomment some code. Just uncomment that. See how Python wouldn't let me, this is an error. So as we've talked about before, like with indentation, just wanted to point that out. If you're running into errors like that, just check your indentation. So you can see here we're printing Y and we're printing X. So this is the new list Y, which is obviously different than X because it's still empty, and we never initialized it up here because this is commented out. So we're actually initializing the variable here to a list, right? And then we're looping through X to fill this list. But since nothing is 10, it's unchanged. And X is also still in its original state. And then here we have two lists that are the same, have the same elements inside of them, but they're two separate lists. So then from here you could do whatever to Y, and it would leave X, your original list, unchanged, which could be good sometimes. Sometimes you just want to run some values or some calculations on a separate data type or data structure or whatever, and leave the original unchanged, and that's one way to do it. One other thing we can do up here is we can say, like, if one, you can do something. So we'll like just build a list of strings really quick, just to give a clear example here. Comment those out. Say x equals and we can just do 2. We'll see what that returns here. So you see that in this one, we're doing a not equal to operator, right? And then we're doing the conditional also. So if the value of num, which we've just named any of these elements as it loops through the original list of x, if it is not equal to 2, then we will append it to y. And that's why you're seeing 1 and 3. So that's good too. You can push all the values in that you want into the list, your new list. So if you just want to take out a value and you don't necessarily know the index of it, or want to use any other method to remove it, that's a way to do it. So when you're using this list comprehension, you can actually do it with any iterable object. So you can do it with a list, a tuple, a set, a dict, whatever you need to do, and that's possible. Another thing we can do is you can just set like a range. So you can just have like z here equals num for num in range 10, right? And then we can just print z. So, and remember that range will just return a sequence of numbers which start at 0, so by default. So you see, we didn't even need anything else. We're just using this range function here to populate the list entirely. We don't have any lists here that have 1 through 10 or 0 through 10 inside of them, or 0 through 9 or anything else. So it's just generating that from this right here, and we're not getting an error. So kind of a cool feature. We can add a conditional too if we want to this exact feature. So we can say if num is less than 3, we can return that, save, do that. So less than equal. So all of your operators will work, and you see we're getting them all back with that z. Another option is you can set all of the values in a new list to whatever you want. So you could just do something like this with a list comprehension. You could do hello world or any string for whatever. And then we could just uncomment that, or whatever. We can even just have a y list. When you're coding, if you ever see stuff like this, sometimes it's just meaning that it's not being used at all. So, but you see here that it's iterating over the list, and it's replacing every value in this list because we have the 4 elements. It's replacing all of them with hello world, 4 new hello worlds. And again, just to reiterate this point, we still have our original list untouched. So a bunch of uses for list comprehension. Okay, so there's a function in Python called filter, and I'm going to be showing something that's kind of similar, but don't get them confused. We can cover filter later, but basically it takes a function and an iterable as its arguments. So I just want you to know that this is not the same thing as filter when you run into it. So you can also have an expression. We'll just set this list to y, and when you're doing this list comprehension, you can just say x if x, and you can do something like is not equal to, we'll just say blue, else black for x in colors. And we will print Y. Spacing, save, and run that. And you see that blue has been replaced by black. So this is a way to just manipulate the outcome. And basically it's saying return the item if it is not blue, and then if it is blue, return black. So if that's confusing, just mess around with it a little bit, as long as you kind of understand how it works. But this is the does not equal, so it's just X is the name of each element as we iterate, and it's saying return X, append it to Y if X is not blue, so that then it returns it right there for this array named colors, or this list named colors, I mean. So it returns X if it's not blue. Otherwise, it just returns black in place of blue anytime blue appears. So if we have multiple blues in this list and we do the same thing, you see that it replaces the first blue and it replaces the second blue. So it's not just one time, it's with every iteration. Alright, so now we'll cover the sort function on a list. So I made a list here of companies, and what sort does is it will list alphanumerically ascending by default. So we can just take this list of companies and we can do dot sort and make sure we execute that, and then we can print companies. If I could stop doing spaces, that would be great. Let's save, run that, and you see that it sorted the list alphanumerically. You can also sort a list numerically. So we'll just make a quick list here. X equals 1. Save that, and we will do x dot sort. So now you see that it sorted it numerically, as well as sorting the other list again alphanumerically. You can also do a descending order, and how you do that is that you can pass an argument into sort here. So we'll just comment that out just so that you can see the difference. So in case you're coding along, I don't want to delete anything. And here we just set reverse equal to true as the argument for the sort function. So we can save that, execute, and you see that it has now sorted it in descending order. We can also just comment that out. It's not running. You can also make a customized sort function, and we'll go ahead and do that really quick. So we can just comment that out. We'll go ahead and we'll even do that just for simplicity and readability. So we'll start a function, and again, functions start with def. We'll just name it myfunc. We will pass a number into my function. And we haven't covered these in depth, but we'll get into that. And inside the function, remember to indent, we want to return. There's a function in Python called ABS. It's absolute value here. And we will just do number minus 100. So this will return the order closest of a number closest to 100. So now we have our list, right? Our X list up there. And we are going to sort X. And here inside of the argument, we're going to put key equals myfunc. So sort will run that function and sort accordingly. And then we will print X. So if any of this is confusing, just hang in there. I know we're covering some new ground. So stuff like this key equals my function. So we're setting the key of what it should be looking for our custom sort method to this custom function that we just wrote. And this is another function in Python. So if this is a little confusing, we can cover absolute at a later time, or you can just go look it up and read about it and test it out. So here you see that we've now sorted it based on the numerical value closest to 100. So it's subtracting 100, and whatever the remainder is, it's sorting it in ascending order basically. So 28 is the closest number out of our entire list to 100, and then 17, then 4. And to just demonstrate this, I'll do like 175, or dyslexia, 175. There we go. So now you see 200 because it's the closest to 175, then 300. So that's a really, really useful thing that we can do with sort. Okay, so I've made this list of companies, and then right below it I've added all of the exact same companies, lowercase. So we'll see what sort does with this. Go ahead and launch our terminal. And you see that even though we're supposed to be sorting alphanumerically, it considers capital letters to come before lowercase letters. So the reason that sort does that and puts them in order with the capital letters first is because it actually sorts the capital letters first. So one thing we can do is in here with companies.sort, we can add a key, and we have that string method that is .lower. So we can do string.lower as our key, and then we can see what happens. So now you're seeing it's sorting it correctly, and it's actually not even changing the case to do so, which is nice. Another method we can use on lists is reverse, so we'll demonstrate that. We'll just do one of our numbered lists here. We will call x.reverse, and then we will print x. Go ahead and down here, execute that, and you see it reverse the entire list for us. All right, that wraps up this section, this episode. I know it was a little bit long, so go ahead and scroll around, mess around with everything until you understand it, and skip around the video, whatever you have to do. But thanks for tuning in.